Let's say you're building a meal planner. You tell it what you want to eat this week, and it helps turn that into a grocery list. On Monday night, you plan your week. Pasta on Tuesday, curry on Wednesday, tacos on Friday. You close the laptop. On Thursday, you're at the grocery store, and you open the app on your phone. Your plan is there. The same meals, on a different device, 3 days later. It seems unremarkable, but look at what just happened. The plan wasn't lost when the laptop closed, and it appeared on a phone that wasn't involved in making it. So it has to be stored somewhere. And clearly, that somewhere is neither the laptop nor the phone. Understanding where it's stored and how it gets to your screen is what this video covers. We're not building anything today. The goal is to understand how apps are structured, because once you see the structure, building becomes much easier to follow. An app is made of two pieces, even though it feels like one. The first piece is what you see: the week view, the buttons, the box where you type in a meal. This gets drawn on your screen, so it runs on your device. The second piece is everything the app knows: your meal plans, your grocery lists, the weeks you've planned before. This information is not kept on your phone or your laptop. It's kept somewhere else, and we'll get to where in a few minutes. The piece you see is called the front end. The piece that stores and remembers is called the back end. It also holds the app's rules. Who's allowed to see which plan? Though storage is the part that matters today. This immediately explains the grocery store situation. Your laptop and your phone were each running their own front end, but both were connected to the same back end. The plan was stored there the whole time, and each device asked for it. So why are apps built as two pieces? The reason is that the two pieces have different jobs, and they change for different reasons. You change the front end when you want the app to look or work differently. A new layout, new colors, moving the grocery list to its own tab. You change the back end when the app needs to store something new: favorite recipes, dietary preferences, more users. Often a change touches both. If you add a whole new feature, you'll usually need a screen for it and storage for it, so both pieces get updated. But the split means each piece can change alone. A redesign doesn't have to touch anyone's saved plans, and reorganizing the storage doesn't have to change anything users see. Having two pieces creates a practical problem. The front end needs to display this week's plan, but it doesn't have that information. The back end has the information, but it has no screen to display anything on. The solution is that they communicate. The front end sends a request. What's the plan for this week? The back end sends back a response. Pasta Tuesday, curry Wednesday, tacos Friday. The front end takes that response and draws it on your screen. And since the back end isn't on your device, these messages travel over the internet. That's why apps need a connection to work properly. Every request and every response is a small message going out to wherever the back end lives and coming back. This is happening constantly in every app you use. When you open the planner, the front end requests your week. When you add a meal, it sends the new meal over so the back end can store it. When you open the grocery list, that's another request. Each exchange takes a fraction of a second, and all you ever see is the result on screen. There's one more thing to know about these messages. The backend doesn't respond in free-form language, the way a person would answer a text. Its responses follow a fixed structure, and the structure is the same every time. In our planner, the response to "What's the plan for this week?" is a list, and each entry in the list contains three things: the meal's name, the day it's planned for, and any notes. Every response to that question has the same structure, because the front end and the back end agreed on the format ahead of time, like two offices agreeing on a standard form. This agreement has a name. It's called the API, the agreement about what can be asked and what structure the response comes back in. When programmers say, API shape. They mean the structure of those responses. This agreement has an important consequence. The front end only depends on the responses having the agreed structure. A list of meals with a name, a day, and any notes. If the responses keep arriving in that structure, the front end works. It can't see what's producing them, and it doesn't need to. That means the back end could be reorganized, upgraded, or replaced entirely. And as long as it keeps responding in the same format, the front end keeps working without any changes. It also works in the other direction, and you've already seen it. Your laptop and your phone are two different front ends, sending the same request to the same back end in the same format. That's why the plan was available in the grocery store. And you can keep going. An iPad app, a smartwatch app, anything that follows the format can connect to the same backend. You set up the storage once, and any number of screens can use it. This is the standard way apps are built, and that independence is the reason. Two questions remain. What actually does the remembering, and where does it run? A database does the remembering. A database is a program with one job: to store records and find them again reliably. Your Tuesday pasta is one record, your Wednesday curry is another. When a request comes in, the database looks up the right records and returns them. Finding things fast, even among millions of records, is the reason databases exist, and it's a problem programmers solved decades ago. Databases are everywhere. Your phone's contacts are in one, your bank balance is in one, and every plan in our planner will be in one too. As for where it runs, it can't be your laptop, because your laptop turns off, and the plan needs to be available whenever any of your devices asks for it. So the database runs on a server, a computer in a data center that stays on and connected around the clock. That's what people mean when they say data is in the cloud. It's on a server somewhere, reachable over the internet. And that completes the picture from earlier. When the front end sends a request, this server is where it's going. For an app like ours, the usual way to get this is a service called Supabase. Supabase provides a database that's already running on a server with the setup and upkeep handled. We're not setting it up today. It's enough to know that when we say backend, this is where ours will live. Let's put the whole picture together. The feature we wanted was a meal plan that doesn't forget itself. You plan the week once, and it's waiting on whichever device you happen to open, including a phone in a grocery store. The screen you plan on is the front end. The plan itself lives in the back end, in a database, hosted on Supabase. The two communicate through requests and responses, and those messages follow an agreed format, the API. Because every device follows the same format, every device gets the same plan back. How the backend knows which plan is yours, signing in, is a story for a later video. A useful exercise: take an app idea of your own and describe it in these terms. What does the user see? What needs to be stored? What requests does the screen need to make? Those three questions cover most of what defines an app, and being able to answer them will make everything we build later much clearer. That's the structure: a front end, a back end, and an agreed format for the messages between them. Every app you use is built on it, and everything we build from here will be too. See you in the next one.